There you go. Awesome. Hey, everyone. We're going to talk a little bit about multi-tenancy, hence the term namespaces up here. Who runs a multi-tenant cluster in this room? That's not a lot of people. Hopefully, I can encourage a couple more of you to explore multi-tenancy after this talk. It's hard, though. If we're talking about multi-tenancy in Kubernetes, a lot of the times we see the namespace as the tenant's realm, right? You create a namespace, you set up RBAC, right? You set up network policies, resource quota potentially. You hand it out to these tenants, and you're really segregating these tenants by namespace. Namespaces are great. They prevent naming conflicts, right? Two pods, I can call both of them database, no problem if they're in a different namespace, right? That's obviously great for tenants. A lot of these isolation controls are designed on a per namespace level. As you can see here, this code snippet for resource quota, right? Everybody loves YAML, so I put it right on the first slide. Obviously a namespace resource. Kubernetes really has that as a unique kind of element to restrict things in the cluster, to segregate things in the cluster. Many tools allow you to filter by namespace, right? That's also great, right? Think of any kind of Grafana dashboards, things like that, right? But what about multi-tenant or multi-namespace tenants in a multi-tenant cluster, right? That's where it gets a little bit more difficult because when you think about, network policies or the resource quota we just saw, right? They're namespace-based. What if a tenant designs the application to be, running across 5 namespaces? It's a problem, right? What do you do with that resource quota? 1 gigabyte of RAM, how are you going to split that up? Just divide it by 5? Just do it times 5? Is that fair to other tenants that just have 1 namespace, right? I don't think that is a great idea potentially, and that makes everything more complicated. So the complexity grows with number of tenants when you have these kind of scenarios. What about access to cluster-wide resources? Think of CRDs, think of controllers, right? One of your tenants, let's say it's an internal use case, pre-production, team wants to install Argo CD, test it out for their new delivery workflow, right? Guess what? They can't install that Argo CD because the Argo CD requires you to install a CRD. So they come back to the cluster admin that handed out the cluster and says like, hey, can you install Argo CD for me? What if there's an Argo CD running, but of a different version than they need, right? You have all these kinds of problems when you run multi-tenant clusters, and the few of you who raised their hand probably know that, right, from running multi-tenant clusters. And that may actually be a reason why some of you aren't doing this. A lot of companies are actually doing this instead. They create a lot of clusters. They create a cluster per team, cluster per customer, cluster per environment potentially, right? There's dev, staging, production times 80 teams, right? Boom, you got hundreds of clusters, sometimes even thousands of clusters, right? And that's pretty problematic, especially as the organization moves towards Kubernetes, adopts more and more Kubernetes across the org, right? The need for clusters just explodes over time. And these clusters are not cheap. Each one of these clusters, obviously, you have to pay for. In a private cloud, it's even worse typically, right? Because you got to upkeep them, you got to upgrade them. So you may have a cheaper resource cost to run them, but then you have a lot of overhead, right, with these clusters. And then on top of that, you actually also got to run all of these different tools in each one of these clusters, right? Because as we all know, a Kubernetes cluster is really not super functional if it's just a bare cluster. You got to have, networking tools like Istio, Cert Manager, an ingress controller, right? Logging, monitoring. There's a whole bunch of tools you need for compliance, security, networking, etc. that need to run in each cluster. And that really adds up, especially if these clusters are pre-production clusters, right? Think of like 500 of these clusters and think of a Saturday afternoon. That's great. Well, all of these clusters are running, nobody's actually using them. And most of the time, the workload that runs on top of them is actually smaller than that platform stack, right? That's pretty problematic. And that's why I think multi-tenancy is really attractive to a lot of organizations. But how are you going to do it, right? Multi-tenancy really has these problems we mentioned earlier in terms of tenant autonomy, right? If we're restricting you to a namespace and you don't have a cluster anymore, that's pretty problematic and not sufficient for a lot of teams. If we go this route, it's super expensive. And ironically, actually, you also don't gain a lot more autonomy in this scenario, because if I'm in central IT and I'm creating 50 clusters and I'm handing them out, I want to typically control that platform stack that's in there. I don't want any of my teams to remove that OPA that I just set up here or change any of the admission control policies. So guess what? Despite me giving you an entire cluster, you still are not going to be cluster admin in that cluster, right? You're still going to be heavily restricted by RBAC and only having access to certain namespaces, right? You may have a little bit more autonomy, but you still don't have full autonomy. We looked at this problem in 2021 and came up with an idea. We were essentially thinking, hey, Kubernetes has users and RBAC permissions, namespaces, right? It's kind of like a Linux host, right? A Linux host has users and it has folders and it has permissions, right? But sharing a Linux host is really difficult without virtualization. So we asked ourselves, what if we added virtualization to Kubernetes? I mean, apart from obviously the nodes and containers and those layers of virtualization, what about the control plane itself? Can we virtualize it? And that's how the idea of vCluster came up. vCluster essentially puts a control plane inside a container, inside a namespace of another cluster. And you can hand out this virtual cluster to a tenant now. That means their kube context points to the API server that runs in this container. And it simulates to be a real cluster, right? That means the tenant has full autonomy, and they can actually be admin because, as you can see in this diagram here, cert manager, OPA, Istio, etc., they actually don't run inside that virtual cluster anymore. They run in what we call host cluster. And then in my tenant namespace, I'm launching this virtual cluster, so I get a blank cluster. And I can actually make my tenant admin inside that cluster, so really elevate their privileges without actually elevating their privileges in the underlying cluster. They still have a namespace, right? So you're kind of getting the best of both worlds. You get much fewer clusters. You have this super lightweight virtualization layer with the virtual clusters on top. And then you have this shared platform stack, which really reduces a lot of the complexity. So instead of having to run 300 Istios and 300 clusters, you get away with running one Istio and one cluster, right? Typically, that's actually not true. Most companies wouldn't just want one giant cluster, right? But maybe you get away with 10, right, instead of 300. That makes a big difference in terms of bottom line cost, but also in terms of management effort, right? And it's just a better architecture when you look at it that way. And that's probably one of the reasons why vCluster became pretty successful over the past 3 years. We have a whole bunch of GitHub stars. There's over 3,000 members in our Slack channel. There's a whole bunch of Fortune 500 companies adopting us. You can see a couple of logos here. Obviously, the biggest ones you can't see the logo of, right? Chip manufacturer, global big four, accounting firm, electronics giant. You can probably guess who these companies are. And we recently raised a Series A backed by Khosla Ventures, one of the first backers of GitLab and one of the first backers of OpenAI. We're really excited about vCluster because vCluster is right in the middle between a namespace, which is super, super lightweight and cheap to run, right? Much, much cheaper than a real cluster. But it also has the benefits of a separate cluster because you really get your tenants, this tenant autonomy and that much stronger isolation, right? Let's say somebody launches a faulty controller that spins up, hundreds of CRDs or secrets or things like that, right? It can actually bring your Kubernetes cluster down. In this case, it can only bring the virtual cluster down. The underlying cluster is totally fine because the control plane is separate, right? You don't give out separate clusters, you give out separate control planes. And there's a difference because a cluster has nodes and networking and a whole bunch of other things. We're just talking about separate control plane. You get full admin access if you're inside. You have reduced complexity in the host cluster, and it's pretty lightweight and cheap to spin up. And I put that logo down there. We're a certified Kubernetes distro. We're actually the only certified distro that is not a full-blown distro, right? Because we're a virtual cluster, but we're still fully compliant. That means if you start handing out real clusters, you can swap this with a virtual cluster, and most of your tenants won't even notice, right? Apart from the fact that they have more privileges now, and they hopefully are going to like that piece. It's pretty easy to try out. We have a CLI that just spins up a vCluster inside a namespace. So if you have a kube context and you can create a stateful set and a service, that's what it does under the hood. It's ultimately just a Helm chart that you install into that namespace. So vCluster create, and off you go. We have a vCluster YAML file that lets you, obviously configure how the vCluster looks and also set up some basic things like network policy, resource quota, limit ranges, etc. in the underlying namespace to set up that basic layer of isolation. And if you're interested in learning more, we're that big orange booth over there. Happy to chat with you. You'll find me on LinkedIn, and obviously you'll find the project on GitHub if you want to check it out. Thank you.